for it to turn red so that it shows that it's recording. Yeah. So now it's recording. That's fine. Hey, I think from now on, if you're having issues with joining the session, right, you keep on joining and leaving. Just leave. You watch the recording. It's fine. Because to be honest, you won't get what's going on. 5, let's say 30 seconds, Nyana, you're in the session. And then the next 30 seconds, you're trying to join in again. You see that you actually won't understand everything. So you end up being forced to watch the recording again. So you might as well just save yourself time now. Maybe go do the prep. When I send the recording in the group, then you go watch the recording because you're gonna miss some important parts in between. So our first thing that we need to do is we check if we ran into a target because they said you should move the target itself, not in anything. And they said every target or each target. The moment they talk about each, there's just not a for loop is involved, whether it's a for each loop or a for loop or a while loop, whatever you want. But usually it's a for loop or a for each loop. In this case, we have to let me look for this person who has his mic unmuted. Who's that? When I say mute your mic, I mean it. Mute your mic. Right now, I'm very patient. Ask those students, second years. There's someone who was doing that and didn't mute. I kicked him out. Told him you watch the recording because clearly you're not serious. Because now you see now you've wasted time me trying to mute you. That's time wasted. So we check if we ran into a target. How do we do that? Remember, it's this type, right? But then just know you pass it in a function, blah, 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 you know all of that. So let's say it's called array world. So I'm gonna say array world, right? But then I need to check. So if statement. So if my array world, right, at that specific coordinate RC is equals to a target, provided that there's a constant called target. Then I found the target, right? But then what is the current location? Remember how to move a player. We always need to keep track of current and destination, right? So that means that I need to generate a destination. Basically, I need to create a destination variables, right, from a destination row and destination column. But then my current is what? RC. Because if this if statement is true, that means at this coordinate RC, I found a target. So basically RC in this context, it means my current row and my current column. Then now I need to find the destination, meaning the location of where I want to move to. And they said you can move anywhere, right? Meaning you can move, you can place it anywhere, right? So I would have to actually use the place feature function. But then remember the place feature function, it needs to take in your, what does it take in? The feature you want to place and its coordinates, right? The random, okay, you can take in, okay, you can ignore passing the row and column, you can, but sometimes we need to know. If I'm not mistaken, let me just double check the previous project we did, the previous paper. I just want to confirm if I'm right. The thing is, right, it doesn't mean the way I'm writing the code, right? I'm gonna repeat. The way I write the code, basically the functions, all the things that I'm taking in, right? It doesn't mean that it always has to be in that format. Don't cram. You can implement this thing in multiple ways. For example, you can implement a game with no record structure, or you can implement a game with a record structure. You see, that's two different approaches already. So yeah, I forgot to mention this. I think I did. This never goes inside the main. Yeah, it should go inside the move function. Because if you put it in the main, it tends to not work entirely. It would like totally, right? Or perfect. They might have some issues. So let me just check something here. Yeah, fine. Yeah, we take in the row and column, right? Because well, this find feature, my bad. I'm mixing them up. It's find feature. You could, yeah, no, let's not, yeah, we're not gonna use find feature. Why are we not using find feature? Because we already have an if statement that checks. So we found the feature. So I don't need to call a whole function for that. It's a simple if statement. The function that I'm more concerned on is the place feature, where we place the feature. Yeah, as you can see. In my case, in this practical, right, I didn't pass in I didn't pass in. Oh yeah, and like I said, it's what is different. Yeah, this is totally different. Yeah, like I said, problems are different. Your place feature function would depend on the problem you're solving. Sometimes you have a simulation, sometimes you don't. So your functions tend to be different. So let me think about it. Yeah, it's gonna be annoying, but yeah, it's fine. It can be annoying, but it's fine. You could do this, right? I'll show you. We're gonna implement that function inside this past paper we're gonna do now. But the place feature function normally looks like this. And then you take in your 2D array, right? I'll just put in the types. I won't put in the names of the variables. And then it takes in your rows, which is an int, and columns, which is an int. And it takes in what else? You want to place the feature, so we need the feature that we want to place, which is of type int. So feature, right? But I'll just say int because I don't want to pass in the variable names. And then let's just say, right, for the sake of this problem, your prac, right? Remember what I said. These functions differ based on the problem you're solving. In this scenario, right, it is, it's like, not really, but technically, yeah. But you could pass in the row and column, right? Like the row and column, int row, int column, right? So that you can keep track of the destination. You could do that, but that's a different approach. Me, I wouldn't advise you to necessarily do that because there's really no need. If there was a need, we could pass. So this is only the things we pass in. Then you have your gen rand, blah, blah, blah. You generate the random row. And then you have that while loop. Remember that while loop. That while is not equals to empty space, right? Then you keep on generating the rows and columns because we don't want to place on top of a location that's already occupied. Then once it's done, it places the feature, right? So that will be the syntax of, let me just leave it there and then delete this. Remember the prac we did this, the past paper we did was different from the way you normally create a place feature function. This is the normal way that you normally create it, whereby you pass in the array, the rows and columns, and the feature. There's nothing like probability, right? That was a different question paper. So we don't pass that here. Obviously, this will place a feature in an empty space, right? So that's where I need to pass it here. Remember, they said that if you move into a target, it has a 50% chance. Before we move it, I need to generate a random, come on, I need to generate a random percent, right? Or percentage. Because they said it has a 50% chance. In a way, you can view when they say that in the past paper or in the question paper, they mean that that's the maximum percentage. By 50%, they mean maximum 50. Meaning the random percentage that you generate, it should be less than or equals to 50. Right? Meaning it starts from 0% to 50%. Technically, you could, right? Technically, but remember, this is based on probability. You could generate a random percentage between exactly 0 and 50%. You could do that. But you see the problem with that? That means you will always move the target, which is wrong because there must be some probability of it not being able to move. So that's why we generated within the full range of what classifies as a percentage, which is from 0 to 100. So you're gonna generate some random percent. So I'm gonna create and say percent is equals to, let's say I've called it gen rand, right? That's the function that generates a random number. We say we want a random number between 0 and 100. Then there's the percentage, we have it, right? Then we check if it is 50%, or check if it has a 50% chance by basically checking if it's less than or equals to 50. So I'm going to say if my percent that I've randomly generated, if that random percent is less than or equals to 50, then it's true that you've reached that 50% chance of it to happening. So now it needs to happen. I need to move the actual target. And they said each target, that's why I put it inside a for loop. So that it keeps on repeating and looking at every single column and row and find each target. If you leave the for loop, it doesn't go through all of the targets. That's that's the downside to that. So now we move the target. Remember what I told you, what I was explaining. The place feature technically does move the target or move that feature technically, right? It technically moves the feature. So since it technically moves the feature, we're gonna use that to place a feature in a way, right? Let me kind of show you the what I mean. In a way, I get this is the target. We want to move it in a random location, meaning it can be anywhere in the game. So let's say, for example purposes, let's say I move it down here. Isn't this the same as like trying to place a feature? Because there was no feature there, right? Meaning it was an empty, and then it has a T now. Technically, we've placed the feature, right? They're kind of synonymous. To move and place, it's synonymous, it's the same thing. So that's why I decided to use the place feature function. So it has placed this feature, but do you notice the problem here? We still have that same feature in the previous location. So we need to update this to an empty space. How do we do that? Remember, it's currently, that's why I was explaining the RC. It's at this coordinate. So that means I need to change that. So before I change that, I need to move the target first. So place feature. This is how, yeah, you have to read. Like I said, I don't know how they expect you to come up with this, but since you're science students, they expect you to use your brain. So we're gonna pass in our array world, then rows, then columns, then the feature itself, which is an int, right? So it's a constant that I need to pass. I need to pass in a target because I want to place a target. And then done, I've placed the target. So this place feature function, right? It technically, right? We are using technically. Technically, it has moved this to that location, right? So basically, this part over here is what the place feature did. Now we're still left with the target in its previous location, or you can call it current location, even though it's really not current. This is where it currently was, right? Which is the location RC. So therefore, yeah, I'll give you an opportunity to ask the question. Let me just finish this up because it's the code, the logic is done. Then now you remove the target from previous location. So how do you do that? You simply go to current, which is RC. So RC is equals to empty space. So empty space. Let's say you've called your constant empty. So I'll just say empty. Then yeah, you're done. That's how you do the 50% part. You basically go through each and every single cell, right? Basically for loops. Then at each and every single coordinate, you check if you've seen a target. If you've seen a target, then generate a random percentage between 0 and 100. And then if that percentage is 50%, basically it's a maximum to 50, meaning it's between the range 0 and 50, basically less than or equals to 50%. You could, right? The thing is, you must use your brain. Common sense is very important here. You could, there's nothing wrong with writing it this way. Let me show you. You say percentage is greater than or equals to 0 and percent is less than or equals to 50 because it's in the range. Like it's supposed to be within this range, including the bounds. So you could write it that way, but common sense, if you're saying what is a number less than 50, it's any number. You could, yeah, to be honest, okay, to be honest, this, like this, right? This would be very correct, right? Very, very direct, but at the same time, it's not necessary because I know for a fact, gen function, right? It generates a random number starting from 50. So that means I can never have a negative number here. So I don't have to worry about what if you leave it like this, right? If you leave it like less than is minus negative numbers are also less than 50 most. Well, that's true, but remember this percentage value is a random number between 0 and 100. So it will never be a negative number. So I know that for a fact. But if it was something different, like maybe really random, we didn't specify a starting and an end, that means it could even be a negative number. That's when the previous solution, which is this is when this would be needed if we didn't specify the starting and the stopping. So yeah, whoever was raising his hand, you can ask your question now. Yeah, this is basically it. That's all you have to do here.
Um, I have okay. The question I wanted to ask is, would see if because you can't place the target anyway. It has to be either around it, right? Basically, it can only move either.
Oh, I did. Okay, I didn't read the whole thing. Let me see. Any cell around it. Yes, technically, right? Technically, still the same thing, right? Hey, Mara, so basically, the solution that I wrote was actually easier. The question gets worse. You still need to go, you'd use the for loop, right, to go through each target. But now they're saying within the around it, right? So what do they mean by that? It's square radius. If you still remember square radius when you're talking about that in the previous paper, that's what they mean. So they mean if your target is here, it can only move this location or this location or this location or this location or this location. So it can only move within those bounds. But then we okay, let's say you do understand the square radius thing, eh? Yeah, the only thing that will change, my logic won't change. You see this part here, right? Maybe yeah, you see everything here. It remains the same. The only thing that's changing is this bounds outside, right? Those are the things that need to change. The if statements and what. So yeah, this question is hard. I don't know how they expect you to understand that, but yeah, it is what it is. So why do I say it's hard? Because remember the formula for square radius, right? Let's use this coordinate as an example. Let's say you're here. Square radius actually starts from the top here. But then what if there's no top and what if there's no bottom? You see the problem. So you need to do checks too to check if it's a valid coordinate. Basically, it's you're gonna use is in world. Hey, this question paper is not it's on steroids. This is a question paper that I would expect a sick test. This kind of standard of a sick test because this is kind of a lot of logic required here. But I do get how to do it, but it's quite a lot of logic. That's the part that I'm just worried about. So let's do that, right? So let me copy this. Okay, maybe I might change it a little bit, but it's still the same logic, right? The only thing that I need to change is okay, you need to move into every single cell as usual, right? So these two for loops are there. And then we need to, oh yeah, to be honest, the checking is fine, this part, because we need to check if we've moved into a target. Then now we need to check within square radius, right? You see the whole square radius thing. So what we could do, right? Okay, I see the logic. I think I should just type it now. I don't know how you guys, it takes experience to be honest, guys. I'm not a magician, right? I wasn't born knowing code. So it takes a lot of experience for you to be able to look at a question and have the answer in your head immediately. It takes a lot of practice. But I see how to implement it. So what we're going to do, right? This is the solution. We're going to go through each cell. We start here, we go there, we go there. We check if it's a target, which is basically this if statement, right? Simple, right? That's straightforward. Whatever coordinate that target is, remember the coordinate for each target is actually RC, right? Remember, it's RC. So you can actually use this RC quite a lot here, right? So that RC, remember the formula for square radius. Let's say, let me change this location. Let's say the target, there was a target here. How do we find the square radius? You always start at the row above it, which is basically row minus one, because you see, if it's a two, the row above it, I had to subtract a one to get the row above it. and we stop at the row below, of which I had to add a 1 to the current row, because the current row is basically where this target is currently at, which is row 2. I need to stop at the row below, which is row 3. So I add a 1 to the current row. So basically, it's what we talked about last time. Where is it? Yeah. Is this part of it that we're talking about. So we can use the same formula. So yeah, like I said, this thing was just on steroids. Let me show you the solution. This thing was on steroids. So now I need to go through the square radius, right? Basically the area surrounding the target. Square radius. Yeah, if you understand logic, you see, logic is a very important topic here. If you can, I would advise you to go practice maths. I know you might be like, well, that won't really make me master coding. Yeah, that's to an extent, but it will help you master problem solving, because computer science just to solve is it's a way to teach you how to solve problems through apps. Basically, okay, you have a problem in the real world. Why don't you make an app? For example, bookkeeping. Instead of using a pen and paper, let's make an app. That's problem solving. So it does maths will help you teach you problem solving. That's very important. Okay, I'll teach you. I'll give you guys a free game. I'll before the when the session ends, I'll show you the websites that I use and how to get discounts and things like that. I'll show you. So go through the square radius. Remember how we go through the square radius? Square radius. It's for loops. Going, do you see how many for loops I'm about to write? I'm about to write four for loops here. So we need to go through the square radius. So for int, instead of r now, I can use something else. Let me use I and j. So for I, we're starting at what row? The row above my current target, right? Remember, my target is currently at what? RC. And the formula to find the row before is to take the current row minus 1. So that means I'm going to say the current row minus 1. Then I say I is less than. Remember, we always stop at exactly those bounds. So I'm going to say less than or equals to. And then I need to stop at the row below where the current row for my target is, which is R plus 1. And this formula, you can try and prove it to yourself. This formula always holds true. That's how you find the square radius. And then I plus plus. We are done going through the rows, right? Now we need to go through the columns. So you actually have four for loops here. So int j is equals to c. For columns, it's the exact same formula. So c minus 1, c is less than, no, not c, j is less than or equals to c plus 1, and then j plus plus. Yeah, like I said, it was actually practically impossible for you guys to figure this code out, because it requires a lot of thinking. Because do you see how many for loops I have here? I have 1, 2, 3, 4, just to move the one target. Yeah, but then remember, we need to do it for each target. That's why we need this first two for loops here. We need to do this for each target. So now we're going through each coordinate, but there's a huge but. Remember what you talked about. What if your location of your target is at a weird location in such a way that there's no there's no right side or left side or above or below. There's no, for example, in this location over here, you see here, there's no above, there's no row above. So if I try to subtract this, it's going to go outside of my game mode. So that means I need to have another if statement within that loop to check if the current coordinates for the square radius is within my game mode. So how do you do that? So it's simply here. It's an if statement. Remember, where I currently am within the square radius is stored by I and J. So I'm gonna check. I'll send you a screenshot. Okay, seems like we're not. Yeah, seems like we're not gonna do the question paper. Yeah, today, because there's quite a lot to explain here. It's fine. You can. I think you can just continue with the practical 8 explanation. You ask me other questions once we are done with this one. So now we need to check if the coordinate is within my game world, right? How do we check that? Let me zoom out a bit. So how do we check that if it's in the game mode? Simple. We have is in world. So if is in world, which takes in the rows, columns, which takes in by rows, we mean total rows and total columns, right? So it takes in rows, columns, and the row and column, basically the coordinate we're trying to check. In this case, remember it's ij. We're trying to check I and j. What is ij stores? What does the ij store? So basically, if this is your coordinate, I stands for the rows, right? It means that this I starts from this row and it ends to this row. That's I. And then j represents my columns, right? Which is the vertical lines, right? But then within the square radius, meaning around this current target. So basically, we start here and we stop at this row. And then column, we start here, we stop at this column. So that's what I and J store. And in other words, right, I and J, they store all of these coordinates, starting here, this one, this one, this one, this one, this coordinate, and this coordinate. That's what I and J store. It could, yeah, it also includes this. Yeah, it also includes this. Yeah, I think it also includes that. But it stores the square radius, right? So this will be I and J, and then this should return true because it needs to be within the game mode. We can't try to move this thing, right? We can't try to move the what is this, the target, if the location that we found is not within the game mode. So we're gonna check if it's in the game mode is equals to true, meaning it is true that the coordinates are within my game mode or within the range of my game mode. If that's true, then you simply want to move the target, right? So the question is, how do you move the target around? Hey, yeah, this question was on. Hey, this question is spiritual. The code I'm about to write, it will make sure it works, but there's a lot of thinking involved in this last bullet. So yeah, there's a 50% chance of moving into any cell. Mm, including diagonal cells. The target cannot move into a player or immovable obstacle or another It can only move into a space or remain in the same position at each turn. Mm. And you must do this for each target. And these people are crazy. They're like, this is madness. Yeah, this person who said this paper is mad. There's no way. Like this is asking too much. Yeah, I think you can report to the faculty or something. This is asking way too much. Right? This is getting out of hand. Dr. Stung is not here for a fun time. I can see. He's clearly not here for a fun time. He's here to make your guys' lives hard. So we need to move the target, and it can move in any location. So, well, basically, there's 50% chance of moving into that location. IJ, yeah, as long as it's not, yeah. I'm thinking about the solution, right? So I see what they want. So I don't know how I'm going to explain it, but let me try and explain it. Remember I and J, right? They store the coordinates of the surrounding area, right? The surrounding area, right? So in order, hey, this actually needs this kind of deep because we might have to introduce labels. If you remember the session we had when we are talking about loops, I did talk about labels in C++. So here we could say outer, right? Because we need to exit leave all the loops. No, I don't have to say, is it here? Nah, not there. No, we don't have to. Okay, it's gonna be trick. Let me think about it. Break. Nah, you can't. It's the thing. I was trying to think of a way to leave the for loop. It's fine though. It's fine. I'll leave it like that. It'll go through all the other coordinates. It's fine. Because remember, you're only allowed to move once because they said each cell has a 50, basically each target has a 50% chance of moving into any cell, right? It can move into any cell. Let me think. Or maybe I'm doing it wrong, like the order. But we still need to, the square radius is very important. I'm just thinking about the order of how I'm structuring my statements. So if each target has a 50% chance, okay, I think let me fix something here. I hope I still have the code. Yeah, I still have it. So what are we going to do? Let me switch it up a bit. What we're going to do, right? We'll only do this square radius thing only if there was a person, if it's within, if it has that 50% chance. If it has, right? So I'll just put back the code. We check if it's a target. We found the target, right? That's fine. Then we generate a random percentage. If that percentage is within the bounds of 50%, then that's only we can do the movement, right? But then the movement should be only, so that means these two parts need to go. The movement should only be in within the square radius. Oh yeah. So technically, yeah, I was, the thing is there's multiple ways to do this thing. I do have an idea now of a different approach. I think but the approach that I was using now, it was gonna be quite long. This one just straightforward, right? So which location, let's see. So if this is the location, right, of where you currently are, the random location where you can place it, it starts from this row and stops at this row and starts at this column and it stops at this column. So we need to generate a random row and a random column, but the random column, the range for it should be a range of within the square radius, right? So how do we go about doing that? So you're gonna have int row. I'll call it row. You can call it current row. That's fine. Int row is equals to gen rand between what? Remember, we talked about it. You start from the row above up to the row below, right? And and then you stop at the row below. Basically, you generate a random number between r minus one and r plus one within that range. But like you see, like I said, there's always a catch to this thing. R minus one might not exist. Do you understand that possibility? It might not exist. Meaning, what do I mean by that? Meaning, like this thing, you need to really think about it. Meaning, if the target is at that location, right? If I say from r minus one, what would be r minus one? It will be minus one. But there's no minus one row. So we need to check if it's within the world. So yeah, there's quite a lot to check here. So let's check if the coordinate. Let me think. Coordinate is within the world. Let me think. The No, the thing is, I want to write short code. I don't want to write a lot of code. That's why I'm kind of thinking a lot because I'm actually writing the code in my head and deleting and checking. Is this right? Is it correct? So don't get confused when I say I'm actually writing the code in my head, trying to find out the shortest way to write it. So we need to check if that location is valid. So if we say is in world and then we pass minus r minus one and column, yeah, it becomes a problem if I do it that way. It's gonna be a lot of code. Basically, maybe like four checks, four if statements, but I don't want that. What if we try to generate the random row and the random column? Yeah, and it's not safe, right? It's not really safe, right? It's not really safe, but it's fine. Let's just generate. It's not really safe to skip the checking part if it's in the world. We'd only check after generating. It's fine. Let's do it this way. The thing is in my head it should work. So I'm sure pretty sure it's gonna work. So we generate from r minus one up to r plus one, right? Okay, I don't know what that was. R plus one, right? Even the column we generated the same way. So gen rand c minus one C plus 1, right? And then, yeah. But then remember what I talked about. This might not exist. This might not exist. This might not exist. This might not exist. So the location might not exist at all. So how do we check if it does not exist? Is involved. So check if location exists. Because do you know why these checks are important, right? You might be like, what if I just keep on my game work? The thing is, if you don't do these checks, your game is gonna crash. And that's the problem. It might not even run and you'll be kept at 40% simply because it didn't do proper logic. That's programming for you. That's why I'm being paranoid. I'm checking everything because the computer wants it to be a perfectionist. You see, I feel like computer science is good for people who have anxiety because anxious people, they tend to check everything. So you'd be very good in that because you'd have to think about it like, what if, what if, what if? All those what ifs is basically if statements checking. So I'm gonna say if the is in world, right, is in world at that specific location, but I need to pass my array. So array world, how many rows, calls. No, we don't pass array world. My bad, my bad, my bad. We don't pass array world. We pass in the rows, columns, and the row and basically the coordinate we're trying to check for, of which is stored inside these variables, row and call. Row is in singular row and call is singular column, not rows, calls. Don't mix them up. Then I'm gonna say is equals to true, meaning it is true that it's within the game mode. Then I'll zoom out a bit so that you can see the code. So we check if this location that I've generated, if is within the world. If it is, then okay, we could okay, let's just assume, right? I agree they said it is a 50% chance, and we're executing this only if that 50% chance was found, right? If it was found, that means we definitely need to move. So how do we force it to move, even though there's a high chance of it finding an invalid row and an invalid column? Remember while loops. So we actually have to do, hey, yeah, this thing wants you to think. We can do a while loop, right? Instead of checking true, because if you say while true, that means the location is valid. We're trying to check for when the location is not valid. So we can check while it's not equals to true. But then if you remember logic, not true just means false. So you could actually just check if it equals to false. By false, meaning it's not in the world. As long as that location we're trying to generate is outside the game mode, keep on generating it. So that means I'm going to actually need to copy and paste these two lines. Basically, what similar, right, to what a place feature function does. Similar. And then it keeps on generating it while what is in world is equals to false, meaning is not in the world. So yeah. Then then after the while loop, right? It's important to understand what is this scope. So when you see the first curly brace, right, this part over here defines the beginning of the loop. That's where the loop starts. And then this is where the loop ends. This loop should end when we actually found a location that's within the world. That means after the curly brace, when the while loop is done, meaning it has found valid coordinates, only then can I place can I move a what is this? Can I move a target? But okay, they said random. I don't have to be that paranoid, but I'm actually thinking about it. To be honest, we're almost done, right? Here you can just move the target, which is kind of simple, right? So you're gonna need to move the target first. So array world at that specific location, not RC, because we are moving it. So we need the destination row and destination column, which is actually this variable's row call. You could actually name it destination row and destination call. That's fine. Me, I just chose to remember you write code in a way that you understand. Me, I understand it to just row call. If you want to put the destination, the word, you can say this is the destination row. That's up to you. But do you see the difference between your code and mine? Mine is short, yours will be long. So that's why some students tend to finish early when they're writing tests, because some people have ways to make things short. So here I'm gonna say row column because that's the destination, right? At that destination, put a target. Then remember what we talked about. If you move something, it still remains in its previous location. So the question is, what is the previous location of where the target was? Remember the if statement we did at the top. We said at RC. So that means I need to change RC to be an empty space. So array world at RC is equals to empty. And then you're done with the movement. And then it'll keep on doing this for all targets. You check if it's a target first, then generate random percent. If that's 50% or it's a maximum 50%. If it's true, then we can move the target. If it's not, remember what they told you. If it's not, you don't do anything. That's why I didn't put an else here, right? We only move if it had the 50% chance. They say it can only move into space or remain in the same position at each turn. So this part, right? I was about to say that you don't need to be paranoid. Why am I saying so? Remember, it's random. There's a high chance of you moving to back to the same location. Remember, it's random. You can move back to the same location. It can be like, oh, let's do random. Let's do a random. Let's generate a random location, and then it goes, it looks. It's like random, 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 and then it goes. Ha! I wanna go here, which is the way the target currently is. So it kind of leaves you to become like you need to be really paranoid to see that, and I kind of have that thing. So if you leave it this way, to be honest, it won't work the way you intended to. Let me show you what I mean. Let's go back to our code. Let's say this is the part we found the location and we made sure that it's a valid location. It's within the world, so we're not gonna crash. It's not gonna crash when we index into the array. So we made sure. Then now we come to this part. Remember, this part is 2 lines of code. We move the target to the destination, but in this case, it's the same location. Basically, row is equals to R and call is equals to C. Because we for some weird reason, C++ decided to generate a random location that points to the current location of which it's currently at. That means it's gonna put back the T, right? This is the first part. I'll get back to you. This is the first part, right? So it's gonna delete this and put a target. But wait, the target was already there. So that's what that's the part is trying that's the part they're trying to explain here in the last bullet. That's the first we did that. We remember still analyzing my code. This is the part we did that. We replaced it with the same symbol. But then in the previous after this, I also write the code that in its previous location where it was, change it to an empty space. But in this case, there was a coincidence. It changed, it generated a random location that points to the same place where it was. So that means it will actually erase it because after placing it again, we have that line of code that changes the previous location to be an empty space. So it's gonna delete this to a dot. That means the target has disappeared from totally from the game world. But that's not what we want. So that's why we need to really understand what the like English is very important to understand because the main important thing here is English. They said it can only move into a space or it remains in the same position. So I have to put another check. Yeah, this is quite annoying to be honest. Yeah, it's getting on my nerves because I feel bad for you guys. I don't know how they would expect you to know this, but yeah, that's ComSci for you. So after I've moved this, right, this will always move. Even if it's the same location, it's fine. You always move it. But the previous location part, I need to make sure that it's not equals to my current row. Basically, it's not equals to R or C. So how do I do that? So check um, to make sure previous location is not the same as the destination. Basically, we generated the same location again of where we currently are. How do you check that? It basically means that, remember I wrote it as a comment here. It means that row is equals to R and col is equals to C. We want to change the previous location only if it's not equals to R and not equals to C. So that's why I'm going to say if row is not equals to R and because it needs to apply for both row and C. So I'm going to use an and my column that I've generated is not equals to the current column. Only then can I move or change the previous location to an empty space. So now I'm gonna change this array world at remember the previous location is stored by the variables R and C. So RC is equals to empty space. But then if you don't do this check over here, there's a high probability of you erasing the target entirely from your game mode, which is wrong. Because remember, they said every time you arrest the target, you get 10 points. That means you lose 10 points already. I want you to take this thing of coding, right? As like, for example, think of it in real world. Imagine your boss said, you know what happened? Yeah, 10,000 just went missing. So this your salary this month is gonna be 10,000 short. Would you agree to that? No, right? So that's why we need to make sure that we don't erase things unintentionally. Things don't go missing and be like, oh, I don't know, oops, something happened. Nah, you can't do that. You need to actually check everything. Make sure things just don't disappear. They only disappear if you've moved into where that location is, and of which the question paper told you to erase it if you've moved into that thing. In this case, they told you if you move into a target, delete the target, but then you also gain 10 units of energy. So in that case, it's a must for me to erase it. But for it to just erase, like for it to be erased automatically with nothing happened, that's wrong. You can't just disappear. So this would be the full code. Yeah, I think it should work 100%. Yeah, yeah, I think it should work 100%. I did apply all the logic here. Yeah, I'll send you this. Let me see. Uh, Yeah, screenshot is not gonna work. I'll just say create it as a TXT file and then send it in the group. So yeah, someone was raising their hand. Can you ask your question?
So I had okay, I have one
Yeah,
question and maybe but okay. So for the if it generates into the same row and column, can't you delete it first and then I can see the C++ reads from top to bottom. So if
yeah,
you
yeah, yeah.
turn it to an empty space first and then if it happens it's in the same row and column, you turn it into a target again, wouldn't that solve in that way? Would see that it replaces the target. So basically instead of
Yeah, yeah, I get you. Yeah, that's actually a smart way to do that. Yeah, yeah, yeah. Like I said, this thing is all about your own approach. Me, I would have approached it this way. You would have approached it in a way smarter way. Because what is basically saying, guys, right, is like, remember, code is right from top to bottom, which is 100% true. Why is if there is that possibility of it generating a random location that points back to where we currently are, why don't we just start by making it an empty space, basically deleting that target, then put the target, meaning that irregardless, even if it's the same location, we're not going to erase the target. So basically, you just simply say array world at RC, which is the previous location, right? Change it to an empty space. So even if R is equals to row and C is equals to call, basically we've generated a random row and a random column that points back to where we actually are. So it would simply delete basically it'll do this. It'll go to that. Remember, we had a target here, right? If you generated a random row and a random column and it points you back to where you actually are, we remember it's right from top to bottom. C++ is going to go here and reach this part. Oh, let's make it an empty space. So it's going to go here, make it an empty space, and then it changes it to a target again. So even if it's the same location, we don't lose the target, which is exactly what I did, but I did it my own way. You could do it this way. This is the this is a genius way of doing it. Yeah, this is the genius way of doing it. Yeah, so yeah,
Uh,
that's correct. It'll work because the main thing is so that you don't lose the target.
okay.
Yeah,
I have, oh, sorry.
yeah.
I have another question. So if Mabunja, how do you make sure that it doesn't accidentally move into another target or player or that
Yeah, my bad on that one. I get I was just focused on like I said, Comsci needs you to be paranoid because what's gonna happen, you are right? It might around the surrounding area. Remember, this thing is all about probability and there's a chance of it being there. What if we had a target here, right? And I'm trying to move this target to this target, meaning it's not occupied, it's occupied. And you're only allowed to move into a place that's not occupied. You do a check again. It's up to you whether you do a while loop separately. But then if you do a while loop separately, blah, blah, yeah, it's gonna be it's best to combine. So what I'm going to do, right? I'm gonna make sure that in my while loop I'm gonna extend. Yeah. Very good questions because I totally forgot to take that into account. So you're gonna check if it is in world, if it's not in the world, right? Because remember this while loop, it's for things things could possibly go wrong. Meaning, number one, it might not be in the game world. That means you need to keep on generating the column. But what if it's not, it's within the game world, meaning this loop ends, right? But the location we found, it's already occupied. So what do we do in that case? Well, we need to generate randomly again. So that's why I said you can't separate the conditions because if you're generating randomly again, what if you generate randomly in a new location that's not occupied, which is outside the game world? So it's actually very problematic if you don't understand logic. So I actually have to combine it and say and here so that both conditions need to be let me think about it. Wait. Let me actually think about it logically. Let me think. If is in world, let's say is in world is false, is true, meaning it is in the world, but it's occupied. So this means this would actually return false, right? Because it is within the world. Remember our question here checks if this returns false. What if it actually the function returns true? That means this whole thing would become a false. So this will be false, right? Just bear with me. That'll be false. But then what if the location that we found is in the world, but it's occupied? So that means true, it is occupied, which is still wrong, right? So we need to make sure that it's like true, meaning it's within the game world and it's not occupied. So I'm gonna do this check. Let me see if I'm just trying to plan my logic. Remember, you could use and or that, and it's kind of hard to get to the conclusion of which one you can use. That's why I'm kind of really taking my time to think about it. So that'll be or, and then I'm gonna check if that location that I've found, right? It needs to be false. If it's false, let me think about it. No, this is kind of tricky. If it's yeah, it's kind of tricky. Do you know why I say so? Because what if the location that I've generated here, right? It's actually outside the world. So I can't come here and write logic like this and say array world and then I'm already indexing because I want to check if it's not occupied. I would have to actually go into the array. It's impossible to do that, right? Um, yeah, it's impossible to do. Well, it's impossible to do that if this first part actually results in a true, meaning the coordinate is not in the game mode. So that means you're trying to pass a coordinate that's not in the game mode. So we actually need to find a more clever way to do that. So let me think about that. If it's if it's in the game mode, it's like that. If it's not in the game mode, why, as long as it's not in the game mode, keep generating. And then after the loop ends, it generates a location that's now within the game mode. But what if it's not occupied? What if it's occupied? That means they have to generate the random rows again and the random column again. So let me think. If it's not in the game mode, and or yeah, I think this would be better. Or because remember, this while loop is to check for wrong things. As long as there's still wrong things, continue running. So I'm gonna use an or because it could be one of them, right? Or both. If I use and would be incorrect because it only checks for when they're actually both correct, meaning they are both wrong. It's the coordinates are they're both outside the world and also point to something that's already occupied, which is incorrect because most of the time it can be either. One can be true, one can be false, meaning it can be true that I'm in my game mode, but false that the coordinate is not occupied is not is aimed. It could be false that the coordinate is aimed, meaning it's already occupied. So you see, you can have a true and a false, or a true or a false. So basically, you can have an or. So that's why I've decided to stop using the and use an or now because I understand the logic a bit better. So I'm gonna say or, so I'm gonna normalize grouping your things. C++ it understands the precedence, right? The order. It uses things like board mass and things like that. So you don't have to worry about that. But it's kind of important to put brackets so that you can also know how things are supposed to be executed in what order. Remember, board mass it starts with BO. It stands for brackets off, meaning you do what's inside the brackets first. So I want to check if it's not in my game mode or it's not an empty space. So that means yeah, it can, yeah, still that I can't shake that feeling that the location might be invalid. I can shake that feeling. So yeah, let's do this. Let's see if the if should I do it inside the while loop? Let me think about that. But then, yeah, this is a very difficult thing to think about. That's what I said to this question paper, the way they set it. This sick test level. It's not the main test level. The main test is usually easier. This is like sick test level. So if this is how the main would look like, I wouldn't advise anyone to write the sick test. Don't. It's not gonna end well. Because you see, I have experienced this thing, but I'm even struggling to come up with the logic. So I wouldn't want to take chances with Dr. Stung. He's not someone to play jokes with. So let's see. If it's not within the game mode, then that you might be asking yourself, why is say like not coming up with a solution? This is why. Because my logic that I want to put here is if array world at that specific row that I've generated and that specific column that I've generated, if it's not equals to an empty space, then generate again. Because I need to make sure it points to an empty space. But then I can't do this, right? Why not? Oh, I can. Hey, yeah, no, you need. I remember now. I'm thinking about the textbook. There's something in C++ called short circuiting, right? It's a very not really too advanced, but it's called short circuiting, right? Circuiting, right? Or short circuiting. Basically, what it does, right? Remember the logic for the in logic, right? Agree you have or, you have and. But you can actually get the full answer of the answer of the full thing only by knowing one side, right? What do I mean? So remember, or it works when at least one of them is true, right? Let me see. Is it no? Did they use and? Okay, let's look at and. If I use or, it's not gonna match. But what is with and, right? For example, let's look at and. And the way it works, right? It needs to be true on both sides, right? So you can use a formula called short circuiting, meaning if I'm trying to check, let's say I'm taking you back to maths, P and Q, right? Let's say we're using P and Q. So I don't actually have to check Q, right? Meaning the second question, Q, if P is false. Because if it's false, that means the whole thing becomes false. So I don't have to check Q. That's what we call short circuiting. It uses its intelligence. C++ uses its intelligence to get to have the conclusion for the full thing only by knowing one piece of it. Basically, if P is false, that means the whole thing becomes false. Why? Because and the way it works is that both need to be true in order for the whole thing to be true. So that means if the very first question, right, the very first thing is false, obviously the whole thing is false. Because I could possibly have false and true, which is false, or false and false, which is still false. So that's why I'm explaining it. That's why I'm explaining this, because you can technically kind of use short circuiting to your own advantage. And then, yeah, I think, we can leave. Let me see. I think, we can leave it because you still kind of do have to check the other one, irregardless of whether it's a true or false. Yeah, yeah, yeah. Oh yeah, I actually have to explain it. Remember, I said this becomes false if the first one becomes false. If the first one is already false, there's no need to check the second one. With remember, the logic is that one of them needs to be false. So P or Q, that means P needs to be true or Q is true, meaning one of them, at least one of them. So that means, following that logic, C++ looks at it in this way. That means that if P is true, I don't need to check Q. The whole thing is true. Because at least one, it means one of them needs to be true. Whether the other one is false or true, it doesn't change the result of the full question. Because the full question is P or Q. If P is already true, that means the whole thing is true. I don't Even if this is false, I don't need to check Q. So technically, right? Technically, like and you wouldn't know this. You wouldn't have actually done this question without knowing short circuiting. And how do I know short circuiting? I read the textbook. So this is what's going to happen. I'm using all. So that means if this is true, right? Let's try. Let's also try to rephrase the question. If this is true, right, meaning it is false that the location is invalid, meaning the coordinate is not in the game mode. What C++ will do, right? It will start here. If this becomes false, then what will it do? How do I put it? This function returns a false, meaning this will be true. This whole part will be true. That means C++ doesn't need to check this. If this is true, right, it means that it's true that it's outside the game mode. So C++ needs to actually go inside here, right? It needs to go inside here and then generates, and then it reaches here and then goes back up and checks the condition. If there's still a true, then it continues running the loop. So let's say, for example, now we generated a new location that's within the game mode. It means that this part becomes false. Then now C++ is forced to check the second condition. Because remember, how it works. It means at least one of them can be true. If it was an and, then it would have simply left the loop. In this case, it's going to go and continue checking the second condition, which is this part over here. So this part over here, right, is going to be checked now. But notice something here. It checks it only if this is false, meaning our coordinates are now in the game mode. within the bounds of the game mode. So that's why I said you need to really, you wouldn't have solved this question without knowing short circuiting. So that means if I try to index here, my code won't crash. So that means I've actually written code in such a way that it will never crash, simply because I understand things like short circuiting. So now I know row and col are valid coordinates. So what C++ will do, right? It will check is if this is true. Is it not equals to an empty space? If it's not, then it generates again. But what if we generate again and it's not within the world, but it's an empty space? Okay, no, that's impossible. Let's say we generate again, but then it's now outside the world again. So that means it has to go back here and check. That's why we do a while loop. C++ does the checks for you. So it's gonna go back, check there, and then sees, oh, it's outside the game mode. And then that part returns true. That means it won't check this part. It generates random rows again and it goes back up. They say now this becomes false, meaning it is now in the game mode. And then let's say by chance too, here now it has generated a location that's actually equals to empty, meaning this is false. This is also false. That means the whole thing is false. So now we've killed two birds with one stone. We found a location that's within the game mode, number one, and it's equals to an empty space, meaning we're trying to move into an empty location. So we've done the right thing, but then technically this thing Comsa will make you become paranoid. If I'm only looking for empty locations, right? What if I generated the same location, right? Meaning it moves to the same where it's currently at. That means my while loop would have to generate, it'll go back and generate again because I put the condition that if it's not equals to an empty space. So that means that in my question paper, I actually neglected this section that I'm about to highlight, this over here. They say that it could remain in the same location, but that means I'm actually ignoring that possibility. So yeah, this thing is quite annoying. I would have to sit down and put a bit more effort into thinking. You see, the main problem here is not the code. You can know the code, but the logic, like, can you think and understand the flow and see and basically trying to tackle all possibilities. That's the main thing here because we're trying to tackle all the possibilities. You could, let me see. Mm, you could technically do this. Yeah, you could, right? If you want to accommodate this feature of that, it can point to things like a target again. You can only check here that if it's equals to, and you can do this, if it's equals to an obstacle, then generate the location again. Because that's the only thing it cannot, the target cannot move to. It cannot move to another obstacle. But that means that the locations that I might generate, they might point to number one, an empty space, or a target again. So this is actually the full code to accommodate everything. Because what we are doing here right now, the way I've changed the code is that after this part becomes false, that means we actually have it. It's true that the coordinates are within the game mode. Then the C++ goes to the second portion of the OR, which is this part. It checks is the location that I've generated, does it point to an obstacle? If it does, change it. Generate the location again. Because it's only allowed to point to an empty space or a target again. So that's the part that's the smallest thing I had to change. Then now it's gonna accommodate this second part of or remain in the same position. That means it will still be accommodate the possibility of it remaining in the same location. So it's a small change, but it actually affects your solution quite a lot. And remember, we talked about this. Usually you can do it two ways. You can put it this way with these two lines of code like this, or you do it my way. You omit this and you simply do the if statement to check. It's up to you. But then to be honest, right? Finally, they'll teach you how to make your code faster. every time you do a check if statements while loop, it actually becomes your program becomes slower and slower and slower. So you must have less, like you must have a very small amount of loops and if statements in your code so that your program becomes faster. So to be honest, this technique that I don't know what your name is, the one of the students who proposed it, it's a faster way to get to the solution. I know it's a small check, it's one thing, but then it kind of affects a lot of things, but it's fine. You choose what you're comfortable with. So this will be the full code. I'll send you the file. Yeah, so this is the full code. I'll leave the comments right there. So yeah. Yeah, so it should work 100% now. If you guys have any questions and you're stuck on a break, you can simply send me a DM. You can let me know. So I'm gonna take more questions now, but then let me just simply stop recording. Okay, let me not stop. Maybe the questions might become very useful. Do you guys have any other questions?
Hello, sir.
Yeah,
Yeah, like I have had a question that that function of checking whether the of moving the target, and are we doing it like on a separate function, or we are doing it inside the function of moving?
it's inside the function of moving. So basically, this code over here that I've written, this loop, everything here, it goes inside the move player function. Any other questions? If you guys didn't have any other questions, I guess that's it for today's tutorial. Good luck with the practical. Hey, yeah, I know this practical is on fire.